All right. So today we are going to discuss about one of the fundamental tool, one of the important tool that is very much used in IT and in DevOps. The name of the tool is Docker, right? So Docker is a containerization tool which is actually making the software developer life easier. Now, what are the things that Docker bring us into a play? Let us discuss it, right? So before proceeding forward, just let us discuss about the logo itself, because whatever logos are present in DevOps, okay, it does indicate, it does have some sort of values, right? So basically, if you see in this specific logo, you can see there is a whale, and on top of it there are a few containers, right? So what actually is happening there is, let us consider an example of a ship, right? So if you want to parcel something from point A to point B from a ship, so how do we parcel it, right? So basically your parcel is stuck into one container, and that container is being shipped from point A to point B, right? The same thing is happening over here, but here the packages are replaced by the files, and the binary is the code that we write, right? That is been transferred from point A to point B. Now what do I mean by point A to point B? So for that we need to first understand what was the actual issue that we were facing earlier, and why we should consider Docker in the first place, right? So we are going to see the traditional approach, what we were facing, and what are the things that Docker actually helped us with, right? All right. So in order to understand Docker, why we should consider it, there are three things, 3 points that we should be aware of, due to which we consider Docker in the first place. First is reusability, meaning we can use Docker multiple times. Now when I say reusability, so in Docker we have something called Docker images, right? Which we can use over the time again and again. So basically that makes this term reusability. Second is lightweight. In order to understand lightweight, meaning we have Facebook, the normal version that we use, which is of 42 MB, and the lighter version that we have, comparatively very less of size, so basically it's of 7 MB or 8 MB, right? But it functions same way as it works in the normal ones, okay, only minor changes. Third is virtualization. Now in order to understand virtualization, I will like to take you over the this screen. So if you want to understand virtualization, let us consider that we are running any additional operating system on an Windows system. So let us take an example of VMware, right? So this is your operating system, okay? Operating system. So here I would be talking about kernel, okay? And here on top of it, what we do usually is we install an hypervisor. So what hypervisor does, it actually help us to install an another operating system on top of the current operating system that we have, okay? So let's say I want to install Linux, okay, and I want to install Mac. Okay, so these are the two operating system that I want to install on my base operating system, that is Windows, right? Now what actually here happens is, let me just add the additional resources as well. So what sort of resources we would be needing over here is, let's say, the networking ports, okay. Second are the disks, and third, let's say, the RAM. Okay, so how does it work? So basically, whenever we are installing any new operating system on top of the hypervisor or VMware, it actually consumes all the resources, because whenever, if you remember, if you install any OS on an hypervisor with an ISO image, so basically the image size of Linux is usually, of the ISO image size is 4 gigabytes, okay, and it won't install partially, it will ask you to install entire thing. So what it will do is, it will ask the hypervisor to provide the resources, and where do hypervisor will take the resources from the base kernel. And why kernel is used to interact with the hardware. So basically whatever is needed to run Linux, it will take from the base OS, right, which is correct. But the problem here is, it will consume entire resources which are actually not even needed, and it will take extra resources. Now let's consider you have 16 gigabytes of RAM available in your PC, and you want to install Linux and Mac at the same time. But what will happen, for Linux it will take dedicated dedicated space, and for Mac also it will take dedicated space. So that is the actual issue we were facing in virtualization. So in order to overcome this issue, we have Docker, right? So this is virtualization, and I'll just create Docker side by side. So till here the picture remains the same. One second. Okay, so I'll compare it side by side. Okay, and here we are talking about Docker engine. Okay, so here what we are doing is we have something called Docker engine. Okay, and this is the beautiful thing that Docker actually is bringing us and making our life easier. Now what is the actual difference between both of them? So let us understand, because here what is happening, everything is been installed from the base thing itself. Basically the hypervisor is taking this entire kernel, but what is happening in the case of Docker engine, here we are having something called containers. Okay, so what actually this containers does is, basically the container doesn't contains the kernel. So basically this specific thing is not present, which makes lives easier, which makes these containers lightweight and actually help us to ship the images and the containers very easy. So if you compare the size both the Linux size from here and in Docker, you will find comparatively a lighter weight over here, because whatever is needed for a container to run, it will definitely ask the Docker engine. Okay, and it will only take those specific files which are actually required, not the entire thing. It will not equip your entire resources. That's the basic difference between virtualization, and that is the beauty that Docker is bringing into a play. All right, so I hope I made you understand what actually virtualization is, or and what actually Docker is bringing us, right? Okay, next is there was one traditional approach that we were following earlier. Let us consider that you are developing one software where your base software is Mac OS, and there you started with your development. Initially when you started with the development, you upgraded your system with Python 3.9 version. Okay, now, based on Python version 3.9, you used few libraries which are actually supported in version 3.9. Okay. Now, you stated as a developer, you stated that yeah, it is working fine for me and everything. I performed the unit test cases, I performed the smoke test case, and everything is running fine on my PC. Now, what happens when this specific thing goes into the client side or into the testing team? They are not even aware that you upgraded the Python version, right? And they are currently running on the older version, that is Python 3.7. Okay, most probably whatever libraries which you used on Python version 3.9 won't be executed, won't be running on the client side, right? So in order to solve this specific thing, okay, Docker came into the picture. And what is this person is doing in between? Basically it's Git. So basically you are pushing your code into the central, where the testing team and the client side, they are basic and the DevOps team are basically pulling the code from the central to the local system and actually executing it. But since you didn't mention that these are the things I have upgraded, like this Python earlier I was using was 3.7, and then I upgraded it to 3.9. Those things were missing. Those sort of communication miss are actually creating a issue. Basically that makes things not to work easier. Okay, so in order to overcome that thing, Docker come into a picture, and actually it solves the purpose. Basically whenever you are running any images, any software through Docker images, you are just defining the pre-security rules on the Docker file, right? And you are sharing that specific Docker file to the client side and the DevOps team. Now whenever they are running that Docker file, they have the set of instruction, which version to use, what commands to use, what are the environment variables to do, which volume to mount with. All the things are being present in that specific Docker file, which actually makes life easier, and actually will be and actually solve the purpose, and makes this thing easier for us. What actually Docker does is actually a good example of resource sharing. Okay, so let us consider two specific example where there is an apartment where each of them actually need a light resource, right? So basically here you can see there are four houses, and all of them need a light resource. So what the engineer did is actually he's providing an individual electric source to each house. which is actually waste of resources, right? That is actually was happening in virtualization. Now when we come to shared resources, basically here in Docker, what is happening is all the four specific houses are referring to one single light source. So that is specifically happening in Docker, where the resource sharing is actually possible. So that's the beauty of Docker, and that is actually possible because this person is working behind it, that is Docker daemon. So what is Docker daemon? Daemon in Linux is basically something which is running behind it, right? So Docker daemon runs on the host operating system. And second thing is containerd. So containerd is actually responsible for running the containers, right? And here Docker daemon is responsible for running containers and managing the Docker services. Okay. And we have something called Docker Hub. So just like we have GitHub to store the code, okay, we have Docker Hub to store the images, right? So we'll come to know in this in the coming videos, but here this is just an introductory part where we are actually seeing what actually Docker is, right? So in order to understand Docker with a very vague example, let us take an example of food. Okay. You have a good friend of yours and you are preparing a meal, right? And you want to share that meal with your friend. So how would you share it, right? You'll just prepare the food, you'll package it and just share that tiffin to your friend, right? Now what will your friend do is he'll open the tiffin and he'll just enjoy the meal, right? The same thing has been done over Docker, where we are actually replacing that tiffin with containers, and the material which is there inside it is been replaced with the Docker file, right? That's the beauty of Docker. So let us go with the actual definition. So Docker is an open source centralized platform which is designed to create, deploy and run application. Okay. Second, Docker uses the container host operating system to run the application. Okay. Third, it allows application to use the same Linux kernel as system on the host computer rather than creating the whole virtual operating system. Remember, I explained you with this specific example. So this third point explains the same. Fourth is we can install Docker on any operating system, but actually Docker engine was natively designed for Linux distros. Okay. Now let us discuss few of the terminologies. First is Docker image. So what is Docker image? Docker image is the actual read-only binary file. It's a template which is used to create Docker containers with all the dependency and configuration which are written inside it. Okay. Now how to write Docker images, how to convert images into container, we are going to see going forward. But let us discuss about Docker containers. Containers are the actual thing which actually holds the entire package of your software which are needed to run the application. Second, container is like a virtualization when they run on Docker engine. So what is the basic difference between Docker images and containers? So Docker images are the prerequisite binary files which are used to create a container. So images at rest are Docker images. Images in execution turns out into a Docker image. Okay. So yeah, let us learn about Docker Hub. So just like GitHub, we have Docker Hub where we are storing the registry which manages all the Docker images. There are two sort of registries that we have. One is public registry, one is private registry. Public registry is available to all, anyone can access. Private registries are specifically to the organization, only the people in the organization can access it, right? So yeah, what is the actual life cycle of Docker? So basically we write a Docker file. Okay, that file turns out into an image, and that image turns out into a container. Let us take an example. You have an assignment which has been given to you, right? One of your sharp minded friend actually writes that entire thing. Okay, here it's the code. Okay, then that specific assignment has been shared with you. You take a WhatsApp photo, okay, and then you share it with people. So you are sharing it in WhatsApp. So that's the basic example in order to understand the life cycle of Docker. So basically you write Docker file, turn out into an image. That image when executed turns out into a container, right? So yeah, that was all about Docker. Now let us go forward and see the actual lab hands-on, right? So yeah, thank you.